Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide everyone with an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available to everyone at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation, where we will be discussing how computers learn. When we say AI learns, what does that actually mean? We know it's not sitting at a desk with a textbook, but it's surprisingly close. In this video, we go inside the machine to try to understand machine learning, and the technique that makes AI get smarter over time without anyone updating its code. Here's something that might surprise you. AI has been learning from you for years, and you've been teaching it without even knowing. Your spam filter got better every single time you clicked Mark as spam. Your phone learned to tell dogs from cats by studying millions of labeled animal photos. Amazon's recommendations based on customers also bought discovered your taste from millions of purchase histories. And your phone's autocomplete? It learned from billions of sentences that real people have typed. None of these were hand-coded with rules. Every one of them learned from examples. That's what we describe as machine learning. Here's the definition. As simplified as I can make it, machine learning is software that learns the rules by studying the answers. Here's why that's a big deal. Traditional programming works like this. You give the computer data and you give it rules and it produces answers. Machine learning, on the other hand, flips that around entirely. You give it data and you give it the correct answers and it figures out the rules by itself. Think about teaching a child to recognize a cat. You don't hand them a rule book about cats with rules like they have 4 legs, pointy ears, and whiskers. You just show them 500 photos of different cats and their brain figures out the pattern on its own. Amazingly, machine learning works in exactly the same way. There are 3 main types of machine learning, each suited to a different kind of problem. The first type is supervised learning, the most common, which trains on labeled examples. The model is given 10,000 emails, each tagged as spam or not spam. The model learns which patterns predict which label. Your spam filter, Face ID, and medical diagnosis tools all use supervised learning. Unsupervised learning, the second type, has no labels at all. The AI is handed raw data and finds its own hidden patterns. For example, a retailer feeds in purchase history data, and the model discovers customer segments by itself, identifying bargain hunters, luxury buyers, and regular customers. The AI classifies them without being told those categories even exist. The third type is reinforcement learning. This is a trial and error learning approach. The AI takes an action, receives a reward if it was good or a penalty if it was bad, and slowly discovers what works. This is how AlphaGo mastered chess, and how a self-driving car's AI learns in a simulation. Here is another simple way to think about this. Supervised learning is like having a teacher mark your homework, highlighting right and wrong answers. Unsupervised learning is like sorting stuff in a junk drawer all by yourself. While reinforcement learning is like learning to ride a bike. When you fall, you adjust, then you get back on the bike and try again. So how does training actually happen? It's a 4-step loop and it repeats millions of times. Step 1. Feed the model labeled examples. Say, thousands of photos tagged dog or not dog. Step 2. The model makes a prediction for every example. At first, it's basically guessing at random. That's completely fine. Step 3. A mathematical tool called a loss function measures exactly how wrong the prediction was. Big error means lots to learn. Step 4. The model adjusts its internal settings called weights to do slightly better next time. Then the whole loop starts again. This process of predict, measure error, and adjust is called gradient descent, and it is the engine that powers virtually every AI model you've ever used. Just imagine if you were learning how to throw darts blindfolded, and someone tells you throw 2 feet left, then 6 inches higher, and you keep adjusting. They keep telling you again and again, until after thousands of throws you're hitting bullseyes. Not from rules, but from feedback. That's basically how the loop works. 2 more concepts every AI user should know before we wrap up. It's important to understand the difference between training and inference. Training is an expensive, one-time process of learning from data. It's like going to school for years, Large models can cost millions of dollars and months of compute time to train. Inference is the process of using the trained model to answer real questions. Like sitting for the exam after years of study, it's much faster and cheaper. When you ask ChatGPT or Claude something, you're running inference, not training. Now let's talk about overfitting. This is what happens when a model learns the training data too well, including its quirks and noise, and then fails on new, real-world examples. Think about a student who memorizes every practice test verbatim. They ace all the rehearsals. But when the real exam asks them things in a slightly different manner, they're lost. Similarly, a good AI model needs to be able to generalize, not just memorize. Machine learning is already woven into our daily life. Email spam filters use supervised learning on millions of labeled messages. Face ID is trained on thousands of photos of your face taken at different angles. Self-driving cars use reinforcement learning in simulation, crashing millions of times virtually so they don't crash in real-life conditions. Medical imaging AI detects early cancers in scans that radiologists might miss. And the conversational AI tools used every day like ChatGPT, Claude, or Gemini are all trained using supervised learning on enormous text datasets, then fine-tuned using reinforcement learning from human feedback. While fraud detection relies on unsupervised patterns to spot unusual transactions in real time. Now for our 3 key takeaways. First, machine learning discovers patterns from examples, and not from hand-coded rules. Second, there are 3 types of machine learning: supervised, unsupervised, and reinforcement, each for a different kind of problem. And the third takeaway is that AI model training involves a self-correcting loop. The loop includes 3 phases: predict, fail, and adjust. Repeated millions of times using the provided data until the model gets it right. Thank you for watching. I look forward to seeing you in our next video, where we explore what is a neural network and go inside the layers of connected nodes that give modern AI its power.